Hi guys, welcome to my channel. In this video we're going to be looking at an interesting question from the AIME, which is an American Olympiad. So let's get straight into it. It is possible to place positive integers into the vacant 21 squares of the 5x5 square shown below so that the numbers in each row and column form arithmetic sequences. Find the number that must occupy the vacant square marked by the asterisk. So firstly, an arithmetic sequence is just a sequence of numbers in which there is a common difference between each two successive terms. So for example, the sequence 2, 4, 6, 8, and so on would be an arithmetic sequence with common difference of 2. And this is going to be the main principle that will help us to solve this question. So the very first thing that we're going to do is we're going to call these four squares A, B, C, and D. And since we know that the numbers in each row and column form arithmetic sequences, we know that there's going to be a common difference in this row. So this is going to give us the relationship between A and C, that 103 minus C is equal to C minus A, or rearranging for C, C is equal to A plus 103 over 2. And we'll call this equation 1. And now let's consider this column and consider the common difference. Well, the common difference here is going to be C minus B, which we can also write as A plus 103 over 2 minus B. And to get to 74, we're going to have to add 2 copies of this common difference. So 74 is going to be equal to C plus 2 copies of C minus B, which is going to be C plus 2 times A plus 103 over 2 minus B. So C plus A plus 103 minus 2B, and C is equal to A plus 103 over 2. And then if we give this a common denominator of 2, it's going to be 3a minus 4b plus 309 over 2. And since this is equal to 74, we can multiply both sides by 2 to get 148 is equal to 3a minus 4b plus 309, or 3a minus 4b is equal to negative 161, and we'll call this equation 2. Now, looking at the square, the common difference here is b. So to find the number in this square, well, it's going to be b plus the common difference, so it's going to be 2b. And this gives us the relationship in the third column. Well, this difference is 103 minus 2b, and it's going to be equal to the difference between d and 103. So now we know that d minus 103 is equal to 103 minus 2b, which can be rearranged for d to give d is equal to 206 minus 2b, and let's call it equation 3. Now looking at the first column, it's pretty clear again the difference is going to be a. So we're going to have 2a in this square here. And if we consider the third row, even though they're 2 squares apart, the difference between 186 and d is going to be equal to the difference between d and 2a. Because the difference between each one is still going to be 2 times the common difference of that row. So now we have that 186 minus d is equal to d minus 2a, which can be rearranged to give d is equal to a plus 93. Call this equation 4. And if we sub 4 into 3, then we get that a plus 93 is equal to 206 minus 2b, or a plus 2b is equal to 113. Now let's double this and call it equation 5. Now recall equation 2. If we do equation 5 plus equation 2, well, this gives us that 5a equals 226 minus 161, which is equal to 65, so a equals 13. And then if we sub this either into equation 2 or 5, we'll get that b is also equal to 50. And then subbing into equation 1, we'll get that c is equal to 13 plus 103 over 2, which is equal to 58. And now we can start to replace some of the numbers in our square. So since we know the values of a, b, and c, we can rub out these squares and put 50 and 100, and also 150 here. And similarly, instead of a and 2a, we can write 13 and 26. And for c, we can write 58. So now we know that the common difference in this row is 58 minus 13, or 45. So that means that in this box, we're going to have 103 plus 45, which is 148. So now it's clear to see that the common difference in this column is minus 2. So therefore, here we're going to have 146, followed by 144, and finally our answer of 142. And as an extra challenge, do you think you could fill in all of the squares? Leave your answer in the comments below. So how did you find this question? Let me know in the comments below. If you enjoyed, please like and subscribe, and share it to a friend to see if they can solve it too.